Hello, Algebra Scholars. This is section 5.2, factoring trinomials that look like this, x squared plus bx plus c. Take note of the fact that there's no coefficient in front of the x squares, which means it's just a 1 right there now. Next section, 5.3, will deal with what to do if there's a coefficient here. But for right now, it's just x squared plus bx plus c. And here are the rules. It says find two numbers that multiply to c, that's the constant term, we call those the numbers the factors, and add up to b, we call those numbers the sum. So two numbers that will multiply together to give you c, and that will add together to give you b. If you can find the numbers, then the problem will factor into x plus the first number times x plus the second number. Here's an example. X squared minus 5x plus 4. So what we do, we'll go over to the side here, and we make what we call a FS chart, where F stands for factors and S stands for sum. So what we're trying to do is find two numbers that multiply to give us C, and in this case C is 4. And we're going to try and find two numbers that add up to b. In this case, b is negative 5. So let's write down all the numbers that multiply together to give us 4. We could have 1 times 4, or 2 times 2, or negative 1 times negative 4, or negative 2 times negative 2. Those are the only possibilities. But if we try adding up these same pairs of numbers, the first pair gives us 5, then we get 4, then we get negative 5, and then we get negative 4 if we add them up. And notice what we're looking for. We're looking for numbers that add up to negative 5, and we see that happen right here. So the two numbers that we're looking for are negative 1 and negative 4. And so if we follow our rule here, it says the problem will factor into x plus the first number. Well, plus negative 1 is really minus 1, and x plus the second number, so plus negative 4, is really minus 4. So that trinomial factors into x minus 1, x minus 4, and you could check your answer by using FOIL. And here are two more examples. So to do all of these, we're going to make factor sum charts. And you don't have to list all of the factor pairs like we did in the first example, but you certainly can if you want to. So two numbers that multiply to give 15 and that add to give negative 8. So there aren't that many possibilities. I'll list them all. 1 times 15 is 15, and if we add those we get 16. 3 times 5 is 15. If we add those we get 8. Negative 1 times negative 15 adds to negative 16, and negative 3 times negative 5, those multiply to 15 and they add to negative 8. So there are our numbers. So then the problem factors quite easily into x minus 3, x minus 5. In the next example, we want two numbers that multiply to give negative 60 and add up to 7. Now we're going to have a lot of pairs of numbers, so maybe let's be a little bit thoughtful about what we choose. Since the numbers have to multiply together to give us a negative, we know that one of the numbers has to be positive and one has to be negative, but the bigger of the two needs to be positive. So for example, we would know that negative 1 times 60 is negative 60, but if we added them up, we would get 59, which is a long way away from 7. So let's maybe skip negative 2 and 30 and negative 3 and 20, maybe negative 4 times 15. Those multiply to negative 60 and add to 11. How about negative 5 times 12? Those add up to 7, and that's what we're looking for. So the problem factors into x minus 5 times x plus 12. This next example is a little bit harder because the numbers are bigger, but it also reminds us that before we start any factoring problem, don't forget the first rule of factoring, which is to look for a greatest common factor. And there is one in this problem. We can factor out a 2x, and what's left over is x squared minus 20x plus 96. And then we would just worry about factoring the trinomial. So look for two numbers that multiply to 96 and add up to negative 20. Since the product, the factors, is a positive number and the sum is negative, we know that both our numbers are going to have to be negative. I don't think it's going to be negative 1 and negative 96. Those add up to negative 97. How about negative 2 and negative 48? Nope. Negative 3 and negative 32? Nope, but we're getting closer. Negative 4 and negative 24? 5 won't go in. Negative 6 and negative 16? Awfully close. Negative 8 and negative 12. There we go. And so this problem factors into, don't forget the 2x that you originally factored out. So 2x and x minus 8 times x minus 12.